Hi there, and welcome to this lesson on A-Level Pure Mathematics 3. We're on Chapter 2, Functions and Graphs, 2.1, the modulus function, and this is the second part of a two-part lesson. And it involves a little bit of work to do with graph sketching in particular. There are really three methods that are taught in this lesson, and I think it's the last one that you'll probably find most confusing. To sketch a graph of a modulus function, the easiest thing to do is to ignore the modulus initially and just sketch the normal function. So if you have to sketch some function f of x, ignore the modulus, just sketch f of x to begin with. Every negative value then has to be changed into a positive value in order to make it into the modulus function. The easiest way to do this is to reflect the negative section of the graph in the x-axis. So the x-axis is acting as the mirror, and the part of the graph which is beneath the x-axis, that reflects upwards. So for example, if you just had to sketch f of x is equal to the modulus of x, or y is equal to the modulus of x, just so you know, I will probably use f of x and y interchangeably. There's a small distinction between the two of them, but for 99% of work at A-level, if you say f of x, if you say y, it really does just mean the same thing. Two different ways of looking at the same thing. Well, that's y equals x, goes up at 45 degrees between the axes. Y equals the modulus of x would be the same as that in the positive part, because when it's positive, nothing changes. But the negative parts will all become positive. And what that looks like is that the negative part gets reflected upwards, reflected up in the x-axis. So the graph on the right is the graph of y equals the modulus of x. Okay, here's an example. I'll let you have a go at this yourself. You may well struggle a bit if you haven't done these before, but have a go. When you've either succeeded or failed, restart the video again. Okay, if you had to sketch f of x equals 5x minus 10, then first of all, you'd do that. You draw y equals 5x minus 10 without the modulus. Here I'm doing it with axes. I'm assuming that you're plotting points. So for instance, if x was 1, y would be minus 5. If x was 2, y would equal 0. And because it's a straight line, once you've plotted 2 points, as long as you haven't made a mistake, you can draw the straight line. Now the modulus of 5x minus 10, this dotted bit here is the bit where the function is negative. This bit is the bit that the modulus will change by flipping it up and making it into a positive. And from a graphical point of view, that's what it looks like. The dotted line gets reflected in the x-axis and heads in that direction. Note, if it was minus 10 on the y-axis here, it'll be plus 10 on the y-axis there. That's the easiest way to make sure you do it right. And that is a sketch of y equals the modulus of 5x minus 10. You'll notice this bit has vanished. It was just working out really to help me there. If you're doing it, I would do that bit lightly in pencil so that you can rub it out and it doesn't exist when you do the final graph. Okay, example 3. Have a go at doing this. There is a slight addition to the question. It now says solve the equation. The modulus of 5x minus 10 is equal to 5. But again, have a go yourself. Once you've had a go, then restart the video. Okay, we'll have a look at this. Well, the modulus of 5x minus 10, that's what we did just now. So that's our starting point where we finished the last question. The example is saying, when does this equal 5? Now, when it says when does it equal 5, it's really the y values you're looking at. So when is the y value for this function equal to 5 as a y value? We've drawn y equals the modulus of 5x minus 10. We need to draw y equals 5. And y equals 5 is just a horizontal line that goes through 5. If ever you're solving an equation graphically, what you're looking for is where the two lines cross each other. So when does the graph for the modulus, the red line, when does it cross the green line, the graph for y equals 5? Well, it's at this point here and this point here. So what you need to find is the x value. So the x value of that crossing point and the x value of that crossing point, which I think are fairly clear from the graph. The first one here is x equals 1. The second one here is x equals 3. Now, if we were doing that algebraically, instead of using an accurate graph, which is what we had then, an accurate graph with accurate axes. If you're solving it algebraically, which is what you will normally have to do in A level, then you actually have to solve two separate equations and combine your answers together. To begin with, you assume that 5x minus 10 is positive. Now, if 5x minus 10 is positive, then the modulus does nothing at all, and you can just take the modulus signs away. And all you have is the normal equation, 5x minus 10 equals 5, which you solve in the normal way. You get 5x equals 15, x equals 3. And x equals 3 was, I think it was the second of the two solutions we had just now. After you've done that, you then have to assume, well, maybe 5x minus 10 is negative. If 5x minus 10 is negative, and this is the confusing bit, if you understand this, you'll have no problems at all. If 5x minus 10 is negative, we have to multiply it by minus 1, because that's what the modulus signs would do. Effectively, a modulus multiplies a negative number by minus 1. If you had minus 4 in there, the modulus would be plus 4. You times it by minus 1. That's what you do with a function. So this is the equation we need to solve if 5x minus 10 is negative. That would give you 10 minus 5x equals 5, 5 equals 5x, and that gives you the other solution, x equals 1, which are, I think, the two solutions that we had before. So two solutions, x equals 1 and x equals 3. First of all, we found them by drawing an accurate graph, and then we found them by using algebra. Okay. Have a go at this one yourselves, doing it exactly the same as we did there. So you've got the equation, the modulus of 2x minus 3 equals 5. You're going to solve it graphically. You're going to solve it algebraically. I'll put up some reminders for you because there's quite a lot of steps here. When you're solving it graphically, first of all, you're going to have to draw y equals the modulus of 2x minus 3. That takes a little bit of time. Then you're going to have to draw y equals 5. Then you're going to have to find the x values where the lines cross each other. Then when you do it algebraically, first of all, you'll have to solve 2x minus 3 equals 5, and then you'll have to solve minus into 2x minus 3 equals 5. Okay, pause the video, have a go doing all of that yourself, and then come back once you've completed it. Okay, we will go through this together. So, step 1 is drawing y equals the modulus of 2x minus 3. We do that, first of all, just by drawing the normal graph, y equals 2x minus 3, which would look like that. Crossing point at minus 3 on the y-axis, 1.5 on the x-axis. This bit down here is the negative bit that's going to have to reflect upwards because we actually want the modulus. And that is it after it's been reflected. Now we do have y equals the modulus of 2x minus 3. Then we need to add to that the graph of y equals 5, which is the horizontal line that goes through 5. And then we look at the two solutions from where the lines cross each other. So there's a crossing point here where the modulus of 2x minus 3 equals 5. And that is at minus 1. There's a crossing point here where the modulus of 2x minus 3 equals 5. And that is at x equals 4. So graphically, x equals minus 1, x equals 4, those are the solutions. Now, as I say, you will normally be doing this algebraically, not graphically. Doing it algebraically, first we assume that 2x minus 3 is positive. If that's the case, you just have the normal equation, 2x minus 3 equals 5, you solve it in the normal way, 2x is 8, x equals 4, which was the second solution we found just now. Then the slightly confusing bit. Now we have to assume that 2x minus 3 is negative. And what would happen if it was negative? Well, if 2x minus 3 was negative, what the modulus signs do is multiply 2x minus 3 by minus 1. That's how the sign gets changed from negative to positive. So that's what we need to do. Multiply 2x minus 3 by minus 1. That gives us 3 minus 2x. And say, when does that equal 5? That we solve in the normal way. 2x will equal minus 2. X equals minus 1. And those are the two solutions that we got before. X equals minus 1 and x equals 4. Now, example 5, we're going to do in a slightly different way. I suggest you don't pause the video with this, but that you just follow it through. If you've done curve sketching before and graph sketching before, then you'll be fine with this. If you haven't, then you should follow it carefully. A sketch of a curve or a sketch of a line is where you do not plot points accurately. You do not have accurate axes with scales. So you draw an x-axis and a y-axis and you put 0 where they meet, but you have no scale. And you do not plot points accurately. What you plot are the key points, the points that matter. And they don't need to be accurate by a scale, but they do need to be labeled. So, doing the sketch. First of all, we'll do a sketch of y equals the modulus of 3x minus 2. Then we'll do a sketch of y equals 2x plus 1. Then we'll do as before, we'll know roughly where the lines cross, not exactly this time. And then we'll go through the whole thing algebraically. So to begin with, we'll do a sketch. Sketch of y equals the modulus of 3x minus 2. Now to do that, we need to do a sketch first of all of just y equals 3x minus 2 with no modulus. And the method is this. We want to find 2 points. Once we found 2 points, it's a straight line. We can join them together. We can draw the line. The first thing we ask ourselves is, well, if x equals 0, what does y equal? If x equals 0, y will equal minus 2. We're just putting 0 into here. Y will equal 0 take away 2, which is minus 2. Now, what that gives you is the crossing point on the y-axis. So we know that this line is going to cut through the y-axis at minus 2. I haven't drawn a scale. I've just done a dot somewhere sensible and then written minus 2 next to it. The second point that we find is what happens if y equals 0. Now, y equals 0 on the x-axis. So if y equals 0, what does x equal? Always slightly harder. If y equals 0, we're substituting y equals 0 in here. So we'll get 0 equals 3x minus 2. And that solves to give us x equals 2/3. That'll be about there somewhere. Again, I'm not worried about exactly where it is. There is no scale on this. And having chosen where I've put it, I do then label the point 2/3. And I can join those points together and I can get the straight line. So that's a sketch of y equals 3x minus 2. It goes in that direction. And I know that it crosses the x-axis at 2/3. I know it crosses the y-axis at minus 2. That's all that matters. Nothing else does. Then we need to do a reflection of the bottom bit so that we get the modulus, because we actually wanted y equals the modulus of 3x minus 2. So this part down here has been reflected up in the x-axis. And then we have y equals the modulus of 3x minus 2. Now note, this was minus 2 down here. That reflects up to plus 2. Always the easiest way to draw it. Step 2, we now need to draw the second thing. So we need to draw a sketch of y equals 2x plus 1, which is the second function, the function on the right-hand side. We go through the same process. If y equals 2x plus 1, we say if x equals 0, what does y equal? Well, if x equals 0, y will equal 1. That'll give us a crossing point on the y-axis. Now, y is 1. 1 is clearly less than 2. That is clearly halfway between 0 and 2. So I would do a dot about halfway between 0 and 2 and then label it 1. We then do the same thing for the x-axis by asking the question, what happens if y equals 0? Well, if y equals 0, we'll have 0 equals 2x plus 1. We solve that, and we get x equals minus a half, which is the point here on the x-axis. Again, we've got 2 points. Once you've got 2 points, you can draw the straight line by joining them together. Now we've got the graph. So we've got y equals 2x plus 1 in green. We've got y equals the modulus of 3x minus 2 in red. And step 3 was noting roughly where the lines cross. It has to be roughly for 2 reasons. First of all, because we haven't done a scale. Because there isn't a scale, I can't say exactly where that crossing point is, and I can't say exactly where that crossing point is. But anyway, the crossing points don't look like they're whole numbers. And there's always a limit to the accuracy of any graph that you do to scale, which is one of the reasons why we do sketches. If you did this to scale and try to get the answer, you get the answer roughly right, but not exactly right. Algebra will allow us to get both of those points perfectly. But anyway, we know roughly where the solutions are. There's one here, which looks like it's about a half, and there's one here, which looks like it's about 4. That does 2 things, having found roughly where they are. I mean, if they tell you, you have to do it, then you have to do it anyway. But the reasons for doing it are twofold, really. It does give you a rough idea of what the answers should be. When we do it algebraically, we should get answers a bit like those. If we don't, we know there's a problem. The other reason for doing a sketch is sometimes you get 3, 4, 5 solutions. It can be more complex than this. If you do a sketch, you can see visually exactly how many solutions there are. So you make sure that you go hunting for the right number of solutions, and you don't stop hunting until you've found them all. Anyway, we'll now do this algebraically. So algebraically, the first step is we assume that this is positive, and we solve 3x minus 2 equals 2x plus 1. We solve that in the normal way. That gives us x equals 3. Now, x equals 3 is this solution. The one that I said was about 4. Well, 3 is about 4. Maybe if I'd been more careful, I would have said 3. But anyway, it was roughly right, and it's certainly a plausible solution. Then the more confusing bit, we're now assuming that this is negative inside the modulus. Now, if it's negative, then the modulus will actually multiply it by minus 1. That's the effect of the modulus on a negative number. So if it's negative, we need to multiply it by minus 1. So you have minus into 3x minus 2, which gives you minus 3x plus 2. We then solve that in the normal way, which gives us 5x equals 1, and x equals a fifth. And we said it wasn't a whole number. So it's 0.2 or a fifth. Normally it's better to go with the fraction than the decimal, although it would be marked right with either. And again, I think we said that that looked like it was about a half. Again, I was a bit casual with that. I think it's clearly a bit less than a half. And a fifth does look like a sensible solution for that point. So the estimated solutions were about a half and about 4. The exact solutions using algebra were x is a fifth and x equals 3. One step more confusing than that is where they make this an inequality instead of an equation. Now, it's the same 2 functions we were just looking at. So the modulus of 3x minus 2 and 2x plus 1, we already know what those look like. So just going back to the graph that we'd already drawn. The red one is the modulus of 3x minus 2. The green one is y equals 2x plus 1. But this time the question is saying, when is the modulus of 3x minus 2 bigger than or equal to 2x plus 1? Graphically, that's when the modulus is above the other line, the line 2x plus 1. So when the red line is above the green line. In this stretch here, the green line is above the red line. So for this stretch in the middle, 2x plus 1 is bigger than the modulus. The 2 bits that we want are the bit on the left-hand side here and the bit on the right-hand side. So that purple stretch now going from a fifth backwards and the purple stretch going from 3 upwards. And that's how you would write down the answer. The modulus is bigger than 2x plus 1 if x is less than or equal to a fifth, so heading backwards from a fifth, or if x is bigger than or equal to 3, heading forwards from 3. And the fifth and the 3, we found those before. So they're the solutions that we found when we did the previous question. Okay, that does get us to the end of this section. If you have the textbook, you can now go to exercise 2A and the last questions, so the last 11 questions from 4 through to 40. Thank you very much for watching, and that is the end of the lesson. So cheerio.